All right, what can we learn about the graph of a polynomial just by looking at its equation? Well, first of all, what's a polynomial? Well, let's just break down the word. Poly means many, and in this case, this nomial, these are going to be terms, so many terms. And these terms are joined together by addition, subtraction, multiplication, and not division. So an example of a polynomial might look something like f of x is equal to 4x to the fifth plus 3x cubed plus 2x squared minus 1. Right? We have a whole bunch of terms grouped together with addition and subtraction, and we could have had some multiplication in there. But there's no division, and we can never have negative exponents. Another important thing about polynomials are that they are continuous for all real numbers and have smooth, rounded curves. So their graphs look like, they're very smooth. Functions that aren't continuous for all real numbers, like things that might have a hole, or a jump or anything like that, these would not be polynomials. Or anything with a very sharp turn, both of these are not polynomials. No way. All right, the very first thing that you want to do whenever you see a polynomial is do the leading coefficient test. And it's because it tells us a whole lot of things. The leading coefficient test will tell us its end behavior, the number of possible roots, and the number of possible turning points. All right, and here's how it works. Let's think that we had some polynomial, ax to the n plus some other stuff. All right, ax to the n, though, this is the one that has the biggest exponent. All right, that's all you really have to look for is the biggest exponent. And right off the bat, that biggest exponent is going to tell you the number of possible roots and the number of possible turning points. And the reason is, the number of possible roots is equal to n. And the number of possible turning points is equal to n minus 1. And if you're wondering what I mean by roots, I'm talking about zeros or x-intercepts. But what about end behavior? Well, we've seen that before. In an older video, we made this table, so you should already have this in your notes, where we talk about like if this number is positive or negative, and the exponent is even or odd, these are the tails. And so we can tell the end behavior using that. And before we go on, let's actually go back real quickly to this roots and turning points situation. All right, so here I have f of x equals x cubed minus 4x squared minus 11x plus 30, right? The only thing I really care about is this x cubed. That tells me my number of possible roots. Well, this graph actually looks just like this, and as you can see, it has 3 roots, 3 x-intercepts. And then turning points are whenever the graph changes direction. So here's a turning point and here's a turning point. So here we saw it had n roots, but n minus 1, only 2 turning points. Now, again, remember that this is possible roots and possible turning points. There won't always be that many. Here we have f of x equals negative 3x to the fifth plus 2x cubed minus x. So the very first thing I do, it's not always the one in the front, it's the one with the biggest exponent. So negative 3x to the fifth, that does have the biggest exponent. So that's what I'm going to focus on. All right, so let's jump down to possible roots. Well, since n is equal to 5, the number of possible roots is 5. And remember, possible turning points is n minus 1, so that would be 4 in this case. It has possible 4 turning points. All right, now in behavior, we see that the 5 is odd and the 3 is negative. The negative 3 is what we're going to deal with first. That lets me know that it ends going down. And because the 5 is odd, the tails want to go in opposite directions. So it starts going up. So from this, I can say that the limit as x goes to negative infinity for f of x, right? Negative infinity is to the left, and on the left it's going up. So this goes to positive infinity. And then I can say the limit as x goes to positive infinity or off to the right as it's ending, it's going to go down, so this goes off to negative infinity. All right, and before we go on, I want you to remember that this is possible number of roots and possible number of turning points. The this does not mean that it definitely has 5 x-intercepts. It just has a maximum of 5 x-intercepts. So a little bit ago, I was talking about number of possible roots, and really that's number of possible real roots, because sometimes you have imaginary, but sometimes it looks like you only have a certain amount of roots, and it turns out you have some repeated roots. So like, let's look here. This is an x to the 4th function, so I have a possible maximum of 4 roots. But see here, I only see 3 roots. And that's because this has a repeated root at x equals 1. But how did I know from the graph that it's a repeated root? Well, I'll tell you. You see, repeated roots, that's not mathematical enough. Let's call it something different. Let's call it multiplicity, which is how many times a particular number is a 0 for a given polynomial. So you see here, f of x equals x minus 3 to the 4th times x minus 5 times x minus 8 squared. Now you may be thinking this polynomial looks a little bit different than the polynomials that we've seen before, where it's something, plus something, minus something. This is because this has already been reduced down to its factors. Okay, it's been factored. X minus 3 is a factor, making x equals 3 a 0. X equals 5. X equals 8. So the multiplicity is just how many times is it a 0? Well, the 3 has multiplicity 4 because the exponent's 4. The 5 has multiplicity 1, and the 8 has multiplicity 2. So what does that tell us about a graph, though, of a polynomial? Well, the even or odd multiplicity tells us what happens whenever you get to that root. So let's imagine that we just have some root, right, some x-intercept. And up here, we're going to say that it has odd multiplicity. All right, so just imagine with me a polynomial with a bunch of other roots, but we're going to focus on this root. So as this polynomial is traveling along, okay, whenever it gets to a root with odd multiplicity, it will continue through the graph, or through the x-axis rather. Now, if it has even multiplicity, it will not continue through, it'll bounce. So whenever I get here and it has even multiplicity, then I bounced. And if it would have hit it from down here, it would have bounced down. All right, so that's all well and good for whenever you're given all the factors, but what if you have to find the zeros? Well, zeros are whenever y equals 0, so we set this equal to 0, and we start factoring. All right, what do these things have in common? An x. So you're left with x squared minus 5x plus 6. Now, I can still factor that. So this is 0 equals x times x minus 3 times x minus 2. Now, I can set each factor equal to 0. So my zeros are x equals 0, positive 2, and 3. And so we see that x cubed, well, x cubed has, the number of possible roots is 3, and look, it has 3 zeros. All right, now let's step it up a notch. Let's factor a polynomial in quadratic form. Quadratic form is au squared plus bu plus c, and u is just some expression of x. All right, so here we have f of x equals x to the 4th minus 3x squared minus 4. All right, so what I'm trying to do is figure out what I can substitute u in for to make it look like this. Well, we start by setting equal to 0, and hopefully we can see that x to the 4th is just x squared minus 3 times x squared minus 4. So what I'm going to do is I'm going to substitute u in for these x squareds. So 0 equals u squared minus 3u minus 4. Because this I can factor. This would be u minus 4 times u plus 1. All right, now that we have it factored, we're just going to plug that x squared right back in for that u. So 0 equals x squared minus 4 times x squared plus 1. And here we see that x squared minus 4, this factors again. So 0 equals x plus 2, x minus 2, times x squared plus 1. All right, so setting everything equal to 0, we see x equals negative 2 and 2. And then x squared plus 1 equals 0. That gives me plus or minus the square root of negative 1. But we're not going to pay attention to those right now because those are not real. So this has two distinct real zeros of 2 and negative 2. All right, what about factoring a polynomial with repeated zeros? Well, we're going to start by setting it equal to 0 and factoring out a negative x squared from each of the terms. So that leaves me with positive x squared plus x minus 2. Remember that all the signs changed because I pulled out a negative x squared. So 0 equals negative x squared times x plus 2 times x minus 1. So this x to the fourth lets me know that it has a possible 4 zeros. Well, I see the zeros at x equals 1, negative 2. And then this one right here tells me that it's at 0. And because it's an x squared, 0 actually occurs twice. It's a repeated 0. I mean, you could actually think about this as negative x times x plus 2 times x minus 1. And that's why you would see that this 0 occurs twice. All right, so now let's try to put it all together. We're going to create a rough sketch of the shape using a number line. All right? So the first thing that we want to do is factor and plot the zeros. So set it equal to 0. These all have a negative 2x in common. So we have x squared plus 2x minus 3. So 0 equals negative 2x times x plus 3, x minus 1. That gives me zeros at 0, negative 3, and 1. And remember, the 0 comes from setting this equal to 0. So now on a number line, I'm going to plot my zeros at negative 3, 0, and 1. All right, the very first thing I want to do is sketch the end behavior. So we've got my zeros marked. Leading coefficient test, this negative 2 lets me know that it's going to end going down. All right? And the odd exponent tells me that it started in the opposite direction. Now, because none of these roots have even multiplicity, they all have multiplicity of 1, so it's odd. That means each time that I hit these roots, I'll continue through the point. And there we have it. That's a rough sketch of what negative 2x cubed minus 4x squared plus 6x looks like. All right, now it's your turn to try. F of x equals x to the fourth minus 2x cubed plus x squared. Pause the video and come back here in a minute. All right, hopefully you got down to your zeros of x equals 0 and 1. And the fact that these are both repeated. So yeah, they're both repeated roots and they both have an even multiplicity of 2. So this positive 1 lets me know that this thing ends going up. And the x to the fourth lets me know that it started going the same way. And because these have an even multiplicity of 2, each time that they hit the root, they bounce off. And so this is a rough sketch of x to the fourth minus 2x cubed plus x squared. All right, and that's all for polynomials. Goodbye.